This right here. So again, to do integration, we just have to follow some basic rules. All right, so let's go ahead and integrate this now. To integrate this, first thing, we can't integrate it in this form. What we're gonna have to do is rewrite it as, I know my integration sign look poor, but we're gonna rewrite it as 4x. Then we know that the 6 over x squared, you're gonna have to rewrite that as 6 times x to the minus 2. I have to rewrite that as 6 times x to the minus 2. And then you can integrate this. So now we can integrate that. When we integrate 4x, we're going to add 1 to the power. This is how we integrate. We add 1 to the power. The power of x right here is 1. So it becomes 2. Then we divide by the power. Plus, integrating this, now we're going to add 1 to the power. So it's going to become 6 x to the minus 1. Then divide by the power minus 1. But when you integrate, you always put plus c, a constant of integration. But then we have to bear in mind that we can simplify it. 4 over 2 is 2. So this works out to be 2x squared. And then 6 times x to the minus 1 over negative 1 is really minus 6 over x. Nice. And so that's how we would integrate this question right here. Just the basics of integration, soft. Looking at this question right here, let's integrate this. Integrate the square root of x plus 2 over root x. To integrate this, you have to use a little bit of laws of indices where we have to rewrite root x. Root x can be written as x to the half power. And then we have plus 2 over root x. Well, this can be written as 2 times x to the negative half. That's how we'd write 2 over root x. This is to the negative half. Yeah, man. Dx, because we're integrating with respect to x. So what we're going to get now is now we can integrate and we add 1 to the power. 1 to a half is 3 over 2. And then you divide by 3 over 2. Then we're going to add 1 to the power again right here to get plus. X to the minus half plus 1, that's going to become 2x to the half. Then we divide it by a half. And that's it. But then of course we know we need to add our constant of integration, so put plus c. So what we're going to get is, this is going to work out to 1 divided by 3 over 2 is 2 over 3. So that's 2 over 3. Then x to the 3 over 2 can be written as x cubed square rooted. This is x cubed square rooted. Then this part is now plus 2 divided by a half. When you divide 2 by a half, we know that we get 4. And x to the half is root x. So this is really 4 root x plus some constant c. 4 root x plus c. So that's what we get when we do this question right here. That's how we integrate that. Nice and easy, soft. So I don't like how this root x look. So let me go ahead and fix this. Let me go ahead and fix this to fix this root x. Just to make it look a little more civilized. This is supposed to be root x. Yeah. All right, now this is known as this is what they call a definite integral when you see the limits now. To do a definite integral, what we're going to have to do is we're going to have to rewrite this as the integral from 0 to 1 of 3x plus 1. We're going to have to rewrite this as 3x plus 1. And then what you're going to have to do, you see that this right here, this square root right here, you're going to have to rewrite it as to the half dx. Yeah, man. That's what we're going to have to do. Rewrite it as to the half. Now you can integrate that, and we know to integrate it, you add 1 to the power. So you add 1 to the power to get 3x plus 1. And then you add 1 to the power is half. 1 plus a half is 3 over 2. But then you always divide it by that power. So you divide it by 3 over 2, divide it by the new power, and then you multiply it by the differential in this bracket. The differential of 3x is 3. So you multiply 3 over 2 times 3. And we're integrating, of course, from, let me change the color, we're integrating from 0 to 1. So what we're going to get is, sometimes they put a bracket around like this. Let's do that. Let's simplify this. 3x plus 1 to the 3 over 2. Now this 3 times this 3 is 9. And so all of this is actually working out to be 2 over 9 multiplied by, this looks like 3x plus 1. 3x plus 1. And this is being cubed and then square rooted. And of course, it says we're integrating from 0 to 1. So since we're integrating from 0 to 1, all I have to do is plug in 1 first. Plug in 1 first, and what we're going to get is plug in 1. 3 times 1 is 3, plus 1 is 4, so that's 4 cubed. So plugging in the 1, we're getting 2 over 9. 2 over 9 times, this is 3 plus 1 is 4, so that is 4 cubed. 4 cubed square rooted. This is what we get, 4 cubed square rooted minus, in bracket, we'll plug in 0 now, we get 3 times 0 plus 1, 1 cube. So this is going to be 2, it's going to be 2 over 9. 2 over 9 times, this is 0, so we get 0 plus 1 cubed, and then we square root that. Then we'll put all of this in our calculator. Now, really and truly, I'm not going to work it out. I'm going to just put it in my super calculator. That's what we're going to do. We're going to put it in the calculator. So it's going to be, let's put a bracket, put another bracket. This is 2. All right, so I just want to get the calculator size right here. All right, so this is now 2. All right, let me fix that. This is fraction button, 2 over 3 multiplied by the square root of 4 being raised to the 3rd power. Close that bracket. Close that bracket, close that bracket, minus. All right, this was not 3, so let me go back and change it to 9. Still getting used to this calculator. Go all the way over here, and this is now 2 over 9. I have to go fraction button, 2 over 9 times 0 plus 1 cube square rooted. That's just 1. So let the calculator work it out for us. This is 14 over 9. So the answer works out to be 14 over 9. So we get 14 over 9. 14 over 9. That's how we do this integration. Now, of course, you know, I love to verify solutions. So we're going to go to Symbolab and we're going to integrate integral from 0 to 1. We're going to go 0 to 1 of, this was the square root of 1 plus 3x, I believe. I sincerely believe that was a question, 1 plus 3x, or 3x plus 1. We should get 14 over 9. There we go, 14 over 9. So we didn't do anything incorrect. We got 14 over 9. They did it by U substitution, but we didn't need to do that. Nice. So we got 14 over 9. Easy. So we know that we're correct. Soft. Nice. Now here's another one to integrate. Integrate 3 over 1 plus 2x squared dx from 2 to 5. To do this sort of integration, what we're going to have to do is we're going to have to change this. We don't like to write it in this form. So what we're going to have to do is rewrite it as, so put back the limits on the integration, but this now we have to rewrite it as 3 times, this is 3 times, this is now 1 plus 2x, not square, but to the minus 2, because we're bringing up the power. This is to the minus 2, we'll bring up the power. By bringing up the power, it makes it easier for us to work with, because now we can integrate a lot easier. Now we can integrate this by adding 1 to the power to get 3 times. This is now 1 plus 2x raised to the, add 1 to the power, adding 1 to the power, minus 2 plus 1 is negative 1. Then we divide it by negative 1. But then we multiply it by the derivative in the bracket. The derivative in the bracket is 2. And we're integrating, of course, from 2 to 5. We're integrating from 2 to 5. Nice. So that's what we do. So doing that now, what we're going to get is we plug in, well, we can actually simplify it inside the bracket some more, just to make inside here look a little bit prettier. What I'm going to do is I'm going to rewrite inside the bracket as minus 3 over 2 times 1 plus x, 1 plus 2x. I'm just fixing up inside the bracket here. It can be written as this. It doesn't matter, it doesn't matter. I just want to write it as this. And we're integrating from 2 to 5. So all we have to do now is input 5 and 2. Inputting 5 and 2, what we're going to get is minus 3 over, this is going to be putting in the 5, it's going to be 2 times, putting in the 5 right here, 2 times 5 is 10, plus 1 is 11, so that's 2 times 11. That's when we input the 5, minus input the 2, we're going to get minus 3 over 2 times, in bracket, 1, well, putting in the 2, 2 times 2 is 4, plus 1 is 5, so that's 5. That's what you get. Nice and easy, soft. That's what you get. So let's work that out now. Of course, you know what I'm going to do. I'm going to draw for the calculator, of course. Drawing for the calculator. Drawing for the calculator, what we're going to get is minus 3 divided by 2 times 11. Close that bracket. Minus, in bracket, let's work this out now. Minus 3 over 2 times 5. Close that bracket. We work this out. We get 9 over 55. That's what that works out to be, 9 over 55. This works out to be 9 over 55. No issues at all, 9 over 55, soft. And of course, you know, we like to verify our solutions. So we're just gonna check it, the integral from 2. There we go, we get our 9 over 55. This is just verifying our solution. Nice and easy, soft. Now these are typical questions that you'll get on an exam. It says the gradient of a curve at a point xy is given by this. And given that P is 1/8 on the curve, find the equation of the curve. If this is what they give you, then what they're giving you is dy by dx. So what they're giving you is dy by dx. And they're telling you that dy by dx is 4 over the square root of 6 minus 2x. I'm going to rewrite that as they're telling you that dy by dx is 4 times 6 minus 2x to the negative half. Just to rewrite it in this form so it's easy to integrate, this is dy by dx from this right here. This that they give you is dy by dx for y prime. That's the gradient function. And so now, in order to find the equation of the curve, in order to get y, you have to remember y is going to be the integral of dy by dx. So y is going to be equal to the integral of 4 times 6 minus 2x. This is how we're going to find y. Integral of 6 minus 2x to the minus half, and we integrate that with respect to x. We integrate this with respect to x. So what we're going to get is, integrating this, we're going to get, add 1 to the power, so we're going to get 4 times, in bracket, 6 minus 2x minus half plus 1 is just going to be a half. And then we're going to divide it by that new power of a half. But while we divide it by half, we then multiply it by the derivative of what's in the bracket, which is -2. Yeah, man, plus some constant c. So all I have to do is simplify this now. Simplifying this, it looks like y work out to be equal to -2 times half is -1. 4 over, that's going to be -4. And then 6 minus 2x to the half can be written as the square root of 6 minus 2x. But then we have plus c. But this will give you a family of curve. But look what they told us now. They told us we have some point p is 1/8. So what you are required to do is you're going to set y equal 8 and x equal 1. So you can say at p, we know that x equal 1 and y equal 8. So let us do the maths. So do the maths now. So y is 8. So 8 is equal to -4 times the square root of. Now when you put x as 1, that's going to be 6 minus 2, which is 4, plus c. The square root of 4 is 2. 2 times -4 is -8. So get -8. So 8 is equal to -8 plus c. And so that means that c equal, bring over the 8 over there, so c equals 16. So since c equals 16, oh good. Oh good. Now we can write down the equation of the curve. So the equation of the curve is y is equal to -4 times the square root of 6 minus 2x -4 times the square root of 6 minus 2x plus c, where c is 16. And that's how we do integration. Easy. So